determine the two variables which are inversely proportional to each other. So in this case, y and cube root of x plus 1. They are inversely proportional. They have a relationship of, for inversely proportional, y equals to k over x, where k can be anything as long as it's a variable, and x can be another variable. In this case, we have y and cube root of x plus 1. Now in the second example, we have y squared is inversely proportional to x minus 1. Then the final one, y plus 1 is inversely proportional to x plus 1 squared. So I'll just like you to write down at the bottom, the k value is actually 2, the k value is 4, and the k value is again 2 in the last case. So they are inversely proportional. As the denominator increases, the value on the left hand side of the equation decreases. One becomes bigger, the other becomes smaller. Okay, so exercise 2. Actually the steps are all the same. It's just that the first line is different. In direct proportion, we would have written y equals to kx. But now, for inverse proportion, we will be writing y equals to k over x. That is the only difference. Everything else is the same. The method of doing it. Okay, so let's begin. Y varies inversely as x. So in the first sentence, we write down y equals to k over x. And this is our formula. And we know that k is a constant. Then they further tell us that x equals to 15, y equals to 3. Okay, that is one set of coordinates of x and y. We can substitute them in. You can call it xo, yo, or you can just directly put in the numbers. So 3 equals to k over 15. Therefore, we find k equals to 45. 3 times 15, 45. And now we update our formula. K is now equal to 45. Let's update it. Y equals to 45 over x. This is now our updated formula. And now we'll always be using this already. Then in part A is already done. Part B, the value of x when y is equals to 2.5. 2.5 is actually 5 over 2. So substitution, 5 over 2, that is 45 over x. Then you carry on with your usual working. You have a fraction equal to fraction, multiply them diagonally. So you end up with, you end up with 5x equals to 90. X equals to, divided by 5, 1, 8. X equals to 18. And then for part C, the value of y when x is 15 over 7. Okay, so now new y, 45 divided by x. X is 15 over 7, so 15 over 7. Whenever you have a fraction in a fraction, you have to make sure it is very clear where's that smaller fraction. In this case, the smaller fraction is in the denominator. So you indicate by a longer fraction line below the 45. So this implies we have 45 multiplied by 7 over 15. So 21. Okay? Any questions? Inversely proportional. If there are no questions, we proceed with the next question. Who needs more time for this? Ning Huan, do you need more time? Okay, next page. Y is inversely proportional to x. Everybody write down the first statement. Okay, is this what you have? Y equals to k of x. Then the next piece of information, y equals to 18, x equals to 4. Okay, do your substitution now. So is this what you have? 18 equals to k over 4. Check. And once you have that, what will you find out next? What will we find out? K, very good. Okay, find K. What is your K? What do you say? You say 18 divided by 4? You sure 18 divided by 4? Look closely. Yes, 18 times 4. Okay, good. So we have K equals to 72. What shall we do with this K? Value of 72. Substitute. Okay, we update our formula now. So y equals to 72 over x. This is now our formula. And that is the answer for part A. And part B, value of y when x equals to 12. Y equals to 72 over 12, which is 6. Simple. Part C, x when y equals to 50. So 50, 72 over x. X. Okay. So you can do this. 50x equals to 72. X equals to 72 over 50 to give us how much? 36 over 25. And just a simple algebra and substitution only in solving. Okay? Now let's take a look at exercise number 4. Read the first sentence. Do you know what's happening in the first sentence? The volume of a given mass of gas is inversely proportional to the pressure P. Do you learn pressure in physics? Do you learn gases? Okay, so what is happening over here, just to give you some idea, you have a syringe. Okay, this the syringe, they stop it at the end. Then okay, let's rewind this. So we have a syringe. Then this is the plunger, okay. Now, there is a little bit of gas over here, right? These are the gas particles. Then when they pull the syringe outwards, you're going to be filling it up with more gas particles, right? More gas particles now. Okay, so the gas particles over here, they have a fixed mass. Then they put a stopper over here. So the mass inside here is fixed, isn't it? Fixed, huh? Number of particles, no change. Now, there is air inside, there is pressure inside. You know the air molecules that are moving around, right? Okay, there is pressure inside. And there is a volume over here. Then you also learn that you can actually compress the gas, isn't it? So what happens when the stopper is over here, and you start to push it, you start to compress. What happens to the volume? When you start to compress, does the volume become bigger or smaller? The amount of space, when you start to push it, compress it, does the amount of space occupied by the gas increase or decrease? Decrease, because you make it smaller, you compress, make it smaller. The volume, when you compress, volume decrease. When the volume decreases, the pressure inside increases. Can you imagine? Can you visualize that? When you compress it, wow, then the pressure becomes very big. The pressure starts to increase. So pressure increases. So it gets harder and harder to compress the more you compress. What happens if you do it the other way around? When you start to pull it outwards, when you start to expand it. Okay, so the opposite of compress will be if you start to expand it, then the volume goes up and the pressure goes down. So this is actually what is happening in the first sentence. Some story behind it. Okay, now that we understand, although it's not needed to understand, just by the first sentence, we are actually able to work on a mathematical aspect of it already. Okay, so let's start. V, given mass, equals to K over P. V equals to K over P. When V equals to 3, so 3 K over 200. So like Zhen Xian mentioned, hey, we can find the value of K already. So K equals to 600. Let me substitute it back here. V equals to 600 over P. That is our formula. Next part, A. Find V when P equals to 150. V, 600, 150, and you get 4. So the value of V is 4. There are actually units over there, so 4 cubic meters. So volume, cubic meters. And then in part B, find the pressure when the volume is 5. 5 equals to 600 over P. P will be 600. 5. We get 120. How Tian finished? Okay, let's try exercise 5 by ourselves. So y equals to k over root x. Do the substitution. Y 7 equals to k over root 144, which is k over 12. Therefore, k will be 7 times 12, which is 84. That's for part A. Then in part B, we now have our updated formula, y equals to 84 over square root of x. So for the value of x equals to 169, when x equals to 169, y equals to 84 over root 169, we get 84 over 13. And then the last part, C. Find the value of x when y is 1 and 1/3. 1 and 1/3 will be 4 over 3. So 4 over 3 equals to 84 over root x. So in order, okay, so in this case, we can multiply this way. Correct, no? 4 over 3, yeah, correct. So 4 root x equals to 84 times 3. Then root x will be 21 times 3, 63. Did I say the answer was 63? Sorry, I made a mistake. So we want to find the value of x will be 63 squared. Not 63, 63 squared. Oops. So 3969. 3969, okay, this is correct. Ten? Okay, exercise 6. The force between two particles inversely proportional to the square of the distance between them. Okay. Let's write F equals to K over distance squared. That is the formula that we generate, yes? Okay, anyway, it's recorded. So F equals to K over D squared. D for distance. Then they tell us that, okay, now the force of attraction is 36 when the distance is R, so R squared. This is our first substitution. Okay, our first substitution. So similarly, we can find the value of K, which is 36 R squared. And you put this back into the formula. So our updated formula is now K, which is 36, R squared over D squared. Wow, looks complicated. We now have 3 unknowns over here, but there's a distinction. This D and the F, they are variables. Whereas this R over here is a constant. They make a distinction between what is a variable and what is a constant. The third line is our updated formula now. So they say find the force when the distance is 3r. Find the force when the distance is 3r. So me being very lazy, I'm just going to write F with a little n. New force. But if you want to write more, you can write new force. New F equals to. You can. But I'm very lazy. I'll rather write Fn. Okay, so my new force is now going to be equal to a constant. The K value is 36r squared divided by the new distance. But I must square the new distance. So what is the new distance? And then I square it. What did they say? The new distance is, it's 3r. So put a 3r inside the bracket. If you have a highlighter, I want you to highlight the bracket and the square outside the bracket. And you put on the note, square the entire distance. Just like what we have been doing for our direct proportion also. It's the same skills. So 36 divided by 9, we have 4 units. Because r squared divided by r squared, you get 1. Okay? Now you should have some more space in your worksheet. Now I'm going to show you the common mistake over here. The next step will be Fn equals to 36r squared over 3r squared. This is the mistake. Wrong. Because then your final answer will be 12. So what happened over here? Where is it wrong? No bracket for the denominator. So it became 3r squared instead of a bracket around the 3r. Then you're just squaring the r. You're not squaring the 3 when you were supposed to square the 3 as well. Okay, that's why I wanted you to highlight over here and square the entire distance, not just part of it. Okay, I'm going to move on now. By the way, this force of attraction between two particles can be a positively charged particle and a negatively charged particle. So there's a force of attraction. If they are nearby, the force is very strong. If they are very far apart, the force is very weak. Another example will be our Earth floating around in the outer space, and then you have some other guy, some astronaut, floating around. If he is very far away, he's not going to feel the gravitational force. But if he is close, like us, we feel the gravitational force in the form of our weight. Okay, another example, magnets. So force of attraction between two magnets, again, inversely proportional to the square of the distance. Very common recurring theme, square of the distance. Inversely proportional to square of the distance. So F equals to K over X squared. First time we can write that already. So when the magnets are 4 cm apart, the force is 3 newtons. We can substitute in the values. 3 equals to K over 4 squared. K, by the way, this comes down to your first line. K will then be 16 times 3, 48. And then you update your formula. F equals to 48 over X squared. Now my formula, for F equals to 48 over X squared. Part A done. Part B, find the force when they are 2 cm apart. So let's write F equals to 48 over 2 squared. So we get 12. 12 newtons. That's a force. Then part C, when they are a certain distance apart, the force is 1.25 newtons. Run out of force when the distance is half. Oh, okay. When they are a certain distance. So certain distance, they don't want to tell you how much that is. We can actually find out if we want to. So let's go ahead and find out. Certain distance, the force 1.25. equals to 48 over a certain distance. So since this is a certain distance, I would want to call it xo squared. Or you can just call it x if you want to. Just take note that later on the x is going to change. Okay? So here, our xo squared is going to be 48 over 1.25. Then, since I'm trying to conserve space, I'm going to remove the square by square rooting the other side. Now, I introduced the square root myself. By right, there should be a plus minus. Right? I introduced the square root, there should be a plus minus. However, the context over here is that x is a distance. You cannot have negative distance. So I conveniently, deliberately leave out the plus minus symbol. It is not that I forgot. It is not that I feel like putting it, I put it. I don't feel like putting it, I don't put it. It is because I know this is a distance. There is no negative distance. Therefore, I leave it as a positive square root. Now they want us to write down the new force. So F new equals to the same 48 divided by the half of the O distance. Wow, no space. Okay, let me just write it on the right hand side. No space already. So new force equals to 48 divided by the O distance. Sorry, the new distance, but you must square the new distance. This is our formula. Right? Our formula is 40F equals to 48 over the square of the distance. Now the new distance is actually half of the O distance. So half of the O distance. Notice I left everything exact form. I didn't want to evaluate. In case I get many decimal, then there will be some rounding off, so troublesome. Okay, now I key everything into my calculator. Root 48 divided by 1.25. I'm going to square that. Then I'm going to divide this by 4. And 48 divided by the answer. So we get 5 newtons. Just like that.